Okay, so now I'm going to go over the more complicated equations and show you some strategies that will help you solve them. If you hear weird sounds in the background, it's my dog. He's being a silly boy. All right, so here we have an equation. It has a radical in it. So the first thing we're going to do is determine our permissible values. So everything under that radical sign cannot be negative. Like if you were to simplify it and get a solution for n, 5 minus n must be greater than or equal to 0. It cannot be negative because, again, we have an even index. So we subtract 5 from both sides, and we get negative n is greater than or equal to negative 5. Then we divide both sides by that negative 1, and we get that positive n has to be less than or equal to positive 5. Remember, when you divide both sides by a negative number, it switches the signs, so you need to switch the sign. I'm then going to do step 2 to, I think, 4 all in one. All in one. So the next thing we're going to do, so this is steps 2 to 4. I'm just going to put them all together. You have the equation. The first thing you're going to do is we're going to isolate that radical. So we're going to subtract n from both sides. We're going to get negative square root 5 minus n equals negative n minus 7. And then we're going to divide by that negative value just to make it a nice positive one so that we get square root of 5 minus n equals positive n plus 7. Okay. We're now going to square both sides. Okay. Square this side and we square this whole side. Okay, so first with the left-hand side, the opposite of square rooting something is to square it. So it just everything that is inside breaks free. The next one is n plus 7 and the whole thing is squared. This is not the same thing as n squared plus 7 squared. This is n plus 7 squared. Okay, it's multiplied by itself. You're squaring the whole side together, and you have these middle terms that come out when you FOIL, so you have to do that. Okay, so you're going to get 5 minus n equals n squared plus 14n plus 49, right? So now you have to look at what you have, and you have an n squared, which means simple algebra is not going to solve this for you. You need to solve using your strategies of solving quadratics. So looking at this, it's going to end up in general form unless I want to complete the squaring, then solve by square root principle, which is a lot of extra work. So I'm going to make one side equal to 0 because that is what you need to do for 3 out of the 4 strategies. So I'm going to subtract 5 and add n to both sides. Okay, so then we're going to get 0 on that one side equals n squared plus 15n plus, I believe, 44. Okay, so now I have to look at this quadratic and think, how am I going to solve this? I could solve this by graphing. I could solve this by factoring. I could solve this by the quadratic formula. To me, I'm going to solve this by factoring because it's a simple factor. There is a 1 in that A position, and I can see the two numbers are going to be 11 and 4, because 4 times 11 is 44, and 4 plus 11 is that 15. That means that my solutions for n, because those aren't my solutions, those are my magic numbers for my factoring. My solutions are n minus 4, and n will equal negative 11. Right. So my next step, my step 5, is to check that with my permissible values. Is negative 4 and negative 11 are both less than or equal to 6. So those are fine. Now I have to check for what we call extraneous roots, which happens when you have a negative in front of the radical usually. So this is going to be step 6, and I have to check both of them. So I'm going to do 6a, and I'm going to check my negative 4 first. So negative 4 minus square root of 5 minus negative 4 equals negative 7. So negative 4 minus 5 minus negative 4 is 5 plus 4, which is 9, and it's equal to negative 7. The square root of 9 is 3. Okay, equals -7, and -4 minus 3 is -7. Does my left side equal my right side? Yes. So the solution of -4 works. Now I'm going to check my -11. So -11 minus the square root of 5 minus -11 equals -7. So -11 minus the square root of 16 equals -7. -11 minus 4 equals -7. And of course, -15 does not equal -7. So -11 is not a solution. So our only solution is x equals -4. That is our solution. We discard the -11 solution because it doesn't work. You can kind of see that if it had been a positive radical, so if it was plus the square root of 16, it would have given us the result we wanted, but that of course wasn't the case. All right, so that is how it looks when you have to discard a solution and when you have to solve using your quadratic knowledge. Okay, so this last example is the most complex. We can see that we have two radicals here. So the first radical is square root 3x. And the second radical is this one here. We have to determine the permissible values or the non-permissible values or restricted values. So 3x has to be greater than or equal to 0. So that means that x has to be greater than or equal to 0. And 5x plus 4 has to be greater than or equal to 0. So solving for x has to be greater than or equal to -4/5. So we look at these two different restrictions. X has to be greater than 0 or equal to 0, and x has to be greater than or equal to -4/5, which is smaller than 0. So overall, whatever we get, x needs to be greater than or equal to 0. Okay. It can't be between -4/5 and 0 because it won't satisfy the second restriction. So the only thing that will work is if everything is either 0 or more. Okay, so that was step 1, is determining our restrictions. Step 2 is to isolate our radical. So we have two radicals. Which one do we isolate? The answer is whichever one we feel like, but the best strategy is to isolate the more complicated one first. So that's the one I've highlighted in yellow. So I have this. So I'm going to subtract that 5 from both sides first. I'm going to get 2 plus the square root of 3x equals the square root of 5x plus 4. All right, you're going to square both sides. Square both sides. All right. So remember that squaring that left side is not just 2 squared plus the square root of 3x squared. It's the whole thing, that binomial times itself. So you're going to FOIL. You can do arrow method. This is you're going to get 2 times 3x, and you're going to get twice of them. So 4 square root 3x plus 3x equals 5x plus 4. Okay, so you'll notice that you still have a radical left over, and that's because those middle terms don't cancel out because it was a trinomial square. So you're going to need to re-isolate those. Okay, so if you're wondering how I got that, again, it was just 2 plus square root 3x times 2 plus square root 3x. It's the 2 times the 2 gave me the 4. 2 times the square root 3x gave me 2 square root 3x, and I had it twice. So that's why it ended up being 4 square root 3x. And then the square root of 3x times the square root of 3x is the same thing as square root 3x squared, which cancels out that root sign. But we still have a square root. So now we get to repeat the process. Okay, so we're going to move everything to one side and isolate that 3x. We're going to subtract 4 from this side. Oh, look, it cancels that out. And we're going to subtract 3x from this side. Okay, so we're going to get 4 square root 3x equals 2x. That's it, because that's it, because the 4's canceled out because they're on both sides. Okay, so I could divide by 4 and then square everything, but then I'd have to deal with fractions. So I'm just going to square both sides now. So I'm going to square, I meant that to be red. I don't know what. I'm writing with my finger, so I'm not the best at that. All right, so I'm going to square both sides. So that 4 gets squared, and then that square root 3x gets squared, which just breaks it out. And then, of course, this 2x gets squared as well, so it becomes 4x squared. Okay. So from here, we have 16 times 3, which is 32 plus another 16 would be 48, I believe. So this is 48x equals 4x squared. And again, we have an x squared, which means we're dealing with a quadratic, which means we need to solve by one of those 4 strategies. I'm going to make one side equal to 0 because that is the main strategy for 3 of the 4 types. And I already know that I have 2 terms, one with an x squared and one with an x. So I'm not going to use square root principle. So I got 0 equals 4x squared minus 48x. Now this is a nice quadratic to factor, so that's what I'm going to do. 0 equals the 4x, and it leaves me with an x minus 12. Right, I believe so. So that means our solutions are x equals 0 and x equals 12. Okay, so those are my 2 possible solutions. Step 5 is to check it with my restrictions. So, or my permissible values. X has to be greater than or equal to 0. This is equal to 0 and this is greater than 0. So far, both my solutions look totally fine. The next thing I'm going to do is plug them in and make sure my left side equals my right side. And just to make this video a little bit shorter, spoiler alert, they both work. So at the end of the day, we get x equals 0 and 12, and those are our 2 solutions. All right, hopefully that helps clarify a bunch of stuff, and let me know if you have any